Okay, so this is project log for GARAM part 29. I did film part 30 before this, so I hope you know that in retrospect. This project log, okay, I gotta put that in 0.5. This project log isn't one where I go hands-on. It's more of a project log where I explain how what flaws our initial purifier had and what this new design, or rather how this new design works. Okay, so let's start. Our initial purifier had two stages, and now this is the modified CAD design, so I sort of lost the initial one, but this upper part remains largely unchanged. This is the ceramic membrane filter with a 0.1 micrometer pore size. This is able to remove most bacteria, actually all bacteria that are larger than 0.1 micrometers, and that it includes E. coli, among other things that can cause several diseases. So, that was our initial design, and then down here, instead of going to this second chamber, our initial design just put a small not ceramic, but activated carbon chamber and filled with activated carbon, and that would, in hindsight, that would have never worked, but at the time we thought that that much exposure to activated carbon would allow for the removal of heavy metals like arsenic, zinc, and copper. Now, this new design, well, before I explain the new design, the problem with the old one was kind of simple. It had two big problems. One was that, actually, it had three. Firstly, we checked, and it was not able to remove the heavy metals because, when you just put a small chamber here like this, then water will just flow through the activated carbon chamber incredibly quickly. And by incredibly quickly, I mean like 10-second exposure time maximum. And that really doesn't allow for the activated carbon to remove all the heavy metal particles. And so it was largely ineffective. The second problem was that this activated carbon chamber had still water inside. And by still water, okay, well, it is still water because, even though this membrane kept flowing, sometimes when you're not trying to drink water, we had a valve here, and you would close the valve, but the water, not, you would close the valve here, but the water would still be stored in the activated carbon chamber because there's no force pushing the water down. And so that was a problem, because still water can attract bacteria. If you leave water still in a climate that is warm, humid, and breezy, actually not, warm, humid, and windy, in an enclosed chamber, then you're very much likely to have bacteria of some sort grow inside of that chamber. And that's sort of the problem we had with our activated carbon chamber. Bacteria started infesting in it. And let's just say it's obviously not ideal when you're trying to remove bacteria in the initial stage. So, okay, so that was the second problem. Now, the third problem was this. The activated carbon chamber, I have the CAD design somewhere down here. There we go. I believe it's... Actually, I have it in three parts, and I'm just too lazy to show it to you. But basically, it needed screws to bolt it down and keep it in place. And then you also needed, hexagonal-headed drivers in order to remove the lid and replace the activated carbon. And that's obviously not ideal when you're installing a purifier sometimes in the middle of nowhere without, those sufficient tools. So I changed that. Okay, so now we're going to address, now I'm going to tell you how I addressed all three problems, or how we addressed all three problems and fixed those problems in our modified design. Firstly, the problem with exposure time. We redesigned the entire activated carbon chamber. So instead of a little chamber to the side here, we now have a dedicated plastic chamber, not plastic chamber, but plastic bucket, about 105-liter capacity bucket here that houses about 20 kilograms of activated carbon and 2 ceramic membrane filters in parallel. Okay, I'll explain why this works. Firstly, if the water wants to exit this activated carbon chamber, it needs to go past. Can I remove this so you guys can see? Yeah. It needs to go past these ceramic membranes. Now, if you know anything about ceramic membranes, you know that they require a lot of gravity-driven pressure in order to push water out. And what that enables us to do, and you also know that it's relatively slow compared to just tap water. And that's because it needs to push water out of its small pores. And normally that's a big downside, right? Because it makes the whole process a lot slower. But in this case, where we actually need to increase exposure time, it works in our favor because it allows. I'm sorry, my throat is getting a bit clogged up, but it allows us to increase the exposure time drastically. So we've measured that when you fill this entire tub full of water, it takes about, this is, as I said, about 100 liters when it's filled to the brim. It takes a couple hours for the water to exit. And I think that's much more than enough time, much more than enough exposure for the water with the activated carbon. And I believe that will, and I say I believe because we haven't tested it yet, but I believe it will be able to remove those heavy metal particles that we were worried about. So that's problem one solved. Problem two was the bacteria problem, and we also addressed that with this ceramic membrane filter. Any bacteria that can grow in this condition will not be able to permeate through these ceramic membrane filters because these filters are the exact same that are used up here, as in they are 0.1 micrometer pore size membrane filters. So they're able to block the progression of the bacteria. Now the third problem was activated carbon removal, or activated carbon refills, right? The refill process was too complicated. So we fixed that by just making this chamber a plastic bucket. You just pop the hood, not pop the hood. You just pop the lid, and then you dig all of this activated carbon out, and then you replace it with new activated carbon. You don't even have to replace the entire thing. Like, it can be tricky to get down here and replace the activated carbon down here. Honestly, all you need to do is replace this, the majority of this, or not the majority, the bulk of this activated carbon, and we estimate that it will still be able to run and deliver the performance that we hope to get. So that's how we addressed all three problems. Now, there's actually a fourth problem that happened during testing when we came back to Korea, and that was the problem of activated carbon microparticles. So if you don't know, charcoal really likes to break. It's really, really brittle. And every time, when you're doing like a barbecue and you accidentally touch a coal, that black powder that comes off of your hand, that's actually incredibly small parts of the activated carbon, not the activated carbon, but those are actually incredibly small particles of the charcoal itself. So it really likes to break. It's very abrasive. And because of that, when you pour activated carbon in here, since activated carbon is essentially just charcoal, but with a bit of post-processing, it still remains incredibly brittle and incredibly abrasive, which means it still breaks easily and it still generates a ton of powder. Now, the problem with powder is that it's not always visible. And if it's not visible, it means it's incredibly small. And by incredibly small, I mean somewhere in the bulk of 1 nanometer to 10 nanometers. That is scarily small. That is scary how small those are. And those are able to permeate through the ceramic membrane filter. And that was a big problem. Actually, the initial problem was that we didn't have this sort of permeation device here. And so not only did the nanometer particles flow out, but visible micro or millimeter particles were also able to exit and get into the end product, that's terrible, right? You don't want to drink your water knowing, or you don't want to drink water that visibly has debris in it. So that was a terrible problem. And we remediated it by placing these ceramic membrane filters here. And these are able to effectively block out any particle that's above 0.1 micrometer in pore size. But we did testing again somewhere near April, or not April, somewhere in the vicinity of February. So somewhere in this second week, we did a couple of tests. And the problem was that the super, super small particles, the nanometer powder particles of the activated carbon, were still able to permeate through. And what that ended up doing, or what the effect of that permeation was that the water, the end product water, was still grayish. We couldn't see any particles, but when we held it up to the light and when we checked it with a spectrometer, we were still able to find that it was not 100% clear water. And that had me worried, because if we're not able to remove activated carbon particles with something as sophisticated as a ceramic membrane, that is very worrisome, especially because, the other solutions for particle removal are very limited and also very costly. So I was worried a bit. And then I had this other event where, well, not this other event, but sort of a forum, right? It was a forum by our club, and it was just really it wasn't even a forum. It was just a presentation for our parents to see what we did this year on our expedition to Laos. And one of my friends, she made a very, high quality sort of documentary style video about our expedition this year, or last year. And during that video, it was actually me in the video. So that was past me, somewhere in August. He mentions that you sort of have to leave the filter flowing for a couple of hours to let all the particles out. And that just sort of hit me. I was like, right. He's right. Particles are always a problem when you use activated carbon filters. Not even the most sophisticated brands like German Brita are able to completely remove activated carbon filters, or activated carbon particles. So instead, what they do is they just put the best permeation device they can find, like membranes or stacks, and they just sort of write on the manual to make the consumer let the water flow, or I don't even know what I'm saying. Let me rephrase that sentence. So what those companies do, instead of just making a truly sophisticated and expensive system to remove all those activated carbon particles initially, what they instead do is in their manual, they write during the first 1 to 2 hours of activation, do not drink the water. Just throw it out, leave the purifier running for about an hour to an hour and a half, and that will remove all the initial particles. And that was the exact solution to this problem. We just put the activated carbon in, we put water in, we activated it. We activated the purifier, we let it flow for about a couple hours, and it worked. No particles, super clear water. Now, we have not yet put it through a spectrometer, so I can't say for certain at this point. But to the naked eye, and to the naked eye with a microscope, and to the naked eye that's looking through the water with a light source, let me just say, subjectively, it was incredibly clear. So I have some high hopes for the results. I think we can initiate the experiment again. Well, not we, but my fellow colleagues at Ongdalsum can initiate it sometime this week or next week. It is a Monday. But yeah, that is about it. So let me just recap the structure of this purifier. This is the first chamber. It houses the ceramic membrane. It removes bacteria. Water goes into here initially, and once it reaches the ceramic membrane, it gets pushed through the pores of the ceramic membrane, and that removes the bacteria. And then once the bacteria is removed, it comes down here through this pipe and into the second chamber, which is full of activated carbon. And here, the water is sort of just stored here until it's able to flow out through the ceramic membrane filter down here. And what that ends up doing is it gives the activated carbon and water enough time together, enough exposure to remove the heavy metals. And then once the heavy metals are removed, it goes through this ceramic membrane filter again to remove any bacteria that might have been created during this instilling process. And then once it permeates through the ceramic membrane, we get our end result, which is pure clear water. I will test it. I will ICP it. I will NMR it. So, yeah. Anyway, thanks for listening to me. I do have a runny nose. But yeah, that's about it for this project log, and I'll see you next time. Bye-bye.